Fine-tuning a model is made easy by the Hugging Face package. To start with, we'll want to initialize the model. So we'll use XLNet for sequence classification, .from pretrained. We'll want to take XLNet base cased. We then specify the number of labels we have in our dataset, and you'll remember we set this earlier, where we have num labels is 4. We then want to provide the ID to label, which is essentially the mapping of the numeric values to their label representation. Using the evaluate package, we can specify which measure of accuracy we want the model to evaluate when it's training. So we'll specify our metric and then use evaluate.load, and here we'll be using the accuracy. But feel free to use whichever method of accuracy you think would be best in your use case. We then need to define a function to compute the accuracy. So we'll define our compute metrics, and from this we take the logits and the labels. We can then use this to compute our predictions. So we'll use np.argmax over our logits, and then we want to return our metric.compute, where our predictions equals our predictions and our references are our labels. This will compute the accuracy for us. The next thing we need to do for preparing to train our model is specify a directory to save our training hyperparameters. You can also use this function to add your custom hyperparameters. So we'll create our training args and then use the training argument function. You'll specify the output directory of where to save your hyperparameters. We also want to specify that the accuracy is to be evaluated at each epoch. So we can add evaluation strategy equals epoch, and we can also specify the number of training epochs. Here we'll specify 3. So now we've set up our training arguments and have a method to compute the accuracy of our training, we're ready to set up our trainer. So we can use the trainer function from Hugging Face. We want to specify our model, and then we need to provide our training arguments, our train dataset and our evaluation dataset, and our compute metrics function. We can then run trainer.train. This will train our model based on all the arguments we've set up in our trainer function. We can see that at each epoch the accuracy is being evaluated. And once this is finished running, we have successfully fine-tuned our XLNet model based on our custom data. The last thing to do is now just evaluate the performance of this model.